At the University of Arizona BioFive Institute, we are focused on tackling complex challenges such as disease, hunger, water and food safety, and other health and environmental issues facing our families, communities, and the world. BioFive brings together hundreds of multifaceted experts that include world-class scientists, engineers, physicians, and computational researchers in a team science environment designed to creatively solve difficult problems. This approach has resulted in disease prevention strategies, promising new therapies, innovative diagnostics and devices, and improved food crops. Join us each week as we talk about science with researchers, staff, and students from the University of Arizona's BioFive Institute.
Hello and welcome to another episode of Science Talks, a conversation hosted by the University of Arizona's BioFive Institute. My name is Sean Caden.
And I'm Dr. Brittany Ullorn.
And two of the main research initiatives at the BioFive Institute center around the brain and infectious diseases. Today, we're joined by Dr. Anita Koshy, an associate professor in the departments of neurology and immunobiology, whose work lives at the intersection of these two health challenges. Dr. Koshy is a physician scientist whose clinical and research interests have led her to specialize in the area of neuro-infectious diseases. Today, we'll be talking with Dr. Koshy about her research, clinical practice, and her journey into this dual career. Thank you, Dr. Koshy, for joining with us today.
You're welcome. It'd be great if you just call me Anita, Sean.
Okay, I can try, but you did work for that MD, so I feel like I have to give it to you. So one of the things I want to start off, I've known you for several years now, and one of my favorite memories of you was coming to one of your Donut Tuesdays or one of your events centered around the holidays. And I find it really interesting that your lab dressed up as characters from the movie Inside Out. And you were Sadness. And that to me seems like the polar opposite of who you are in almost every interaction I've had with you. How did you get to be Sadness?
Because in my postdoc lab, I had been the blue Care Bear. And so I had all the blue stuff. And I just so happened, I think I bought a blue wig for that one. But otherwise, okay. I think I had the all blue outfit. That's how I got to be that.
That's how you get to be that. Well, and I thought Arun, who's another member of your lab, as Anger, it was really off type. I don't think I've ever seen Arun angry ever. So that was definitely interesting to see the character choices that you made, because I thought Joy would be perfect for you.
Well, Joy, Hannah was Joy. And so she also had the hair and I think maybe the yellow dress. And Arun went with Anger, I believe, again, because he had a red shirt.
Based it off the wardrobe. I like that.
Exactly.
I just appreciate the fact that as scientists and researchers, you guys are really about community, and community is really important. And I appreciated taking part in that, even though I was not dressed. I think I was dressed as Robert, the building manager, that day.
Oh yes, because you're wearing a Hawaiian shirt.
Because I was wearing a Hawaiian shirt. That was my my pretty sad attempt at dressing up. But we'll dive right into some of the science elements. So your research focuses on Toxoplasma gondii. This is a parasite that infects up to 1/8 of the world's population. Tell us a bit about this parasite, what it is, how we might become infected with it, and how does it cause disease?
So it is a eukaryotic, or basically humans are eukaryotic. So it has a nucleus, so different than a bacteria, has a nucleus where it has or viruses where it stores all its genetic material. And it's a single-celled parasite. So lots of people think about parasites as the worms that infect you, like hookworm or tapeworms. And those are multicellular parasites. And Toxoplasma is a single-celled organism and is akin to, or it's a cousin of malaria, which would be the most famous probably of the parasites in this group. So Plasmodium is the name of that parasite. And Toxoplasma and Plasmodium are very different, except in how they invade the cells. So Plasmodium you get from a mosquito, and Toxoplasma you get usually from eating or drinking contaminated food or water. And I'll sort of go through the life cycle real quick, and then it'll explain how you get it through contaminated food or water, which is that cats are the only definitive hosts. So they're the ones where if you get infected with toxoplasma, if a cat gets infected, it can have sexual recombination. And then they basically poop out a specific form of toxoplasma called an oocyst. And if that ends up in your water and you don't have access to clean water, you can get toxoplasma that way. The other way people generally get toxoplasma, and that actually brings up the other way people get it is, or in theory, they get it is from the kitty litter. If you're cleaning out your kitten's litter and you get your hands dirty and don't wash them, then that's another way that you can ingest an oocyst, which is why pregnant women aren't supposed to change kitty litter.
Oh.
So then the other way people get toxoplasma is that if once the parasite infects an animal and it has a huge host range, the parasite goes all over the body, gets cleared out, except for a couple organs, including the muscle and the brain. But the muscle is important for this, which is that it sets up this persistent infection. So things like pork or chickens. And then if you don't cook that meat all the way, you can then ingest one of these cysts or the persistent form, and then you can get infected that way.
Okay.
Fascinating. So I know you were talking a bit about how it potentially can go to your brain. Is that correct?
Correct.
So I know that part of your work also has to do with understanding the immune response within the central nervous system. So how does that tie into your research on toxo, and how does that kind of help inform the way we treat other diseases in the brain that can involve inflammation or an immune response?
So at the moment, it doesn't inform how we treat, but that's the long-term goal, which is that this parasite that goes to the brain is able to persist there in multiple mammals, so mice, cats, humans. And in order to establish that persistence, it means it and the brain immune system have sort of sorted out how to survive each other. And so if Toxoplasma has figured out how to manipulate the brain immune response or evade it or change it to persist, then it means as we can learn about that, so how does Toxoplasma do that, then maybe we can sort of take those tools and apply them to diseases such as stroke or MS or neurodegenerative diseases, where we think neuroinflammation plays a much bigger role than was initially recognized. So it's sort of how do we tune the immune system in a positive way.
And you were just saying something, talking from two different hats, the scientist and the physician. So it's the scientist who's asking the questions about how something interacts with our bodies. It's the physician who's saying, how can we identify it within a patient? Talk about your balancing of those two roles and how, I mean, because I know you're in our building and then you're over at the College of Medicine, and you're walking halls in the hospital. I've seen you over there on many occasions. Talk about those two roles and how you balance those.
Well, so I, by intent, have chosen only to see patients in the hospital. Mm-hmm. And the reason I do that is those weeks that I'm there, like that's what I do. But once I walk out of those 2 weeks, then I don't have follow-up patients and things like that. And that's important because obviously if you run a clinic and a patient calls, you can't not answer that patient's question because you have a grant deadline. Like that's just wrong priorities. So if I do it as all inpatient work, then as soon as I'm done, someone else is taking over for that patient. And so there's that continuity there. But at the same time, I could sort of break up my life in a way that works out for me.
So people don't track you down over to our buildings. They know you're a researcher in the Keating building. I promise I don't give out your phone number.
They definitely don't track me down. And it's interesting, like there are a number of physicians who give out their cell phones. And I'm just like, whoa, that is just not me. Like that.
I feel like that's very dangerous. You're just asking for calls at any time of the day.
Exactly. But the residents will track me down if there's a patient that I can be particularly helpful for. So like some infectious disease of the brain comes up, or there's a concern about it, then they'll track me down.
And I think too, when you have, you mentioned boundaries, because boundaries are really important. We interviewed Dr. Michael Johnson, and he said he starts conversations, if he starts a conversation off with, I have this crazy idea, that's going to lead to him probably doing more work. So establishing boundaries is really important. And to be able to do two very intense jobs with very different focal points is not easy, I would imagine. So it's good that you have a practice. I heard you also like to run. And that,
well, I don't know that I think I would say that I like to be in shape. I don't actually like to run.
Okay.
But it is the most efficient way to stay in shape. And I used to really want to stay in shape because I played a lot of soccer. But you know, running you can do anywhere, right? When you're traveling, all you need is your shoes, basically. And I've gotten by. Generally, having running clothes with you is also a bonus.
Yes.
Yeah, I know that's always been one of my favorite ways in grad school, especially traveling to conferences and going to new places. I think the best way to see a new city is to just take a jog around. So I definitely am with you on that one.
Yeah. Absolutely, except you probably don't get lost like I do. So I have to have a very well mapped
I have to
out
bring
route.
my phone with me. I'm not that good. I will get lost. But I am curious. So what led you to this dual career path? What made you want to say, I want to do both, you know, the research and I want to be in the clinic? Well, not in the clinic, but in the hospital setting, working with patients.
Okay, so I always tell people, like, okay, so I have two parents, both are physicians. Neither of them was pushed me toward being a physician. And I went to college thinking, like, the world does not need another Indian physician, right? Because I know a lot of them. You probably know many of them as well. And so I got to college, and if you're sort of Indian, from an Indian family, you grow up at that time with the idea that you can be a physician or you could be an engineer. Those are your options, right? You're going to be in science. And so I went to college and was like, okay, well, I don't want to be a physician. I'm going to be an engineer. And then quickly discovered that I didn't like the classes in engineering. Like, it wasn't math, like theoretical. It was like problem set after problem set. And so then I took some biology classes and really enjoyed that. And really, I think ended up as a physician because I knew what that was, right? I mean, I don't think I understood what a PhD was, or that you could go that route, but I knew what a physician was. And so I think that's how I ended up being a physician, and then ended up at Duke University. Like many academic centers, has lots of physicians who run labs. And really that sort of changed my idea. And I had really liked being in a lab. Well, I had a terrible experience my first lab in undergrad. I worked with someone who's very, very smart, but was what I like to say is probably an example of why tenure is maybe something we should reconsider every so often. He had maybe passed his prime, and the way of explaining things he didn't understand was he would say it louder. And so that was a terrible experience. I was like, oh, this is awful. And then I ended up going to a second lab that was run by an MD PhD, and it was a neuroscience lab. And I loved that lab. And, you know, if you culture neurons, they look just like these drawings that this guy, Ramon Cajal, made. And that, you know, it just, they're so pretty. And so I just had a great experience there. And I think that really made me think about doing a career in science. But then, of course, I'd had this experience where it was really positive with someone who had an MD. I knew what an MD was. So I went to Duke, and Duke's a unique place in that you spend a year as part of med school doing research. That's just part of its curriculum, yeah. And so that was great for me because I hadn't done enough research to have any idea if that's really what I wanted to do. And so I got to spend a whole year doing research and said, yep, this is what I want to do. And so that's, I think that those experiences of seeing a lot of MDs who ran labs, and then being in a lab in my 1 year, I was in a lab of an MD who ran a lab. And so it was a path that made sense to me.
And you love writing grants.
Yeah, I hate writing grants. Like, this is one of those things where I'm like, and this is where being Indian really bites you in the butt, which is that, like, you know, my parents are always like, your English grades, a B, fine. What's your math grade? right?
What's your math grade?
But now you really need to write and convince those reviewers
Oh.
that you're worth
Exactly.
funding.
So yeah,
Wow.
so I actually am not so kind to my children. I'm like, let's go over why writing is important for all
Writing
of
is
us.
important. We've had those moments where we talk about the various aspects of the grant, and there's like the project summary, which is written for someone like myself, which is 3 sentences summing up the grant. And then there's the research strategy, which is 12 pages of a lot of pretty figures and stuff I have no idea what it means. I've tried reading through Dr. Felicia Goodrum's, specific aims, and I said, you know what, that sounds great. I don't know what it means, but it sounds great. But I mean, that part of it is talking to which audience. So as a physician scientist, do you find that those audiences are, obviously you're talking to patients, but when you're talking to other physicians, is that audience much different than talking to other researchers?
So I would say yes, in that. So being a physician is really different than being a scientist, in that being a physician is really about pattern recognition, right? And there's some pattern recognition in science, but especially in the inpatient, it's sort of like the patient looks like this or they look like this. What are the possibilities, right? And you have to have a relatively good sense of pattern recognition, just because otherwise it'd take you forever, right? You can't spend like 3 hours on every patient being like, well, it could be 900 things. How will we ever narrow it down, right? And so being a scientist is really like, oh, here's a new pattern, or here's a pattern that was seen in a different organism or a different context. How does that fit and how do they connect? But it is much more about discovery. And so the positive about being a scientist that I think informs being a physician, and I try to help residents and medical students think about that, is thinking about data and what that data means, right? So if I tell you this vaccine is X% effective, well, what does that mean? And how did they figure that out? And so what does that mean for our population? Like, because so we give drugs all the time, right? It's like, okay, we're going to give you this drug because it prevents atherosclerosis in this amount of time or whatever. But it's important to know, hey, we treat everyone with these so that we'll prevent a heart attack or stroke in 2 people, right? So it's a different way of thinking about it, so that I try to make sure the residents and students can at least think about it that way, because how you think about it matters because of risk benefit ratios, right? So is this really worth doing this to this patient if we think our chance of finding it is 1 in 1,000? And if it's so low, does that actually mean when we get a positive result, it's actually a false positive? So
It sounds like you're brushing off some statistics and math skills there when you start putting in
yes,
those terms.
Yeah.
yes, for sure, definitely. But I think that's one of the benefits I think that's something I bring to residents and students that they don't get from necessarily all the other faculty in the neuro department, is that I think about data differently.
Yeah, that makes sense. I think that's something unique that you definitely can bring to the table and, impart on those med students. But I'm also just thinking about, a mentorship relationship. Obviously, you're imparting a lot of information on the students and the residents, and also the, students and the trainees in your lab. But what are some of the things that they have maybe taught you, whether that's, looking at the research differently, or just a different philosophy that they might have that inspires you? What do you learn from your mentees?
Yeah, so I would say 2 things. But so the medical students and residents, I think I do teach them stuff. They actually teach me things as well, but just because I've seen more patients. And again, it's about pattern recognition. And a lot of times that just has to do with the number of patients you've seen. For the grad students and postdocs in my lab, I sort of feel like I'm not sure I teach them anything, right? I think they teach
That's
me.
not true. Come on.
Well, I think they teach me a lot more. It's more of a conversation, right? It's about being positive and having them, like, here's an idea. What do we think we should do next? And having them always come up with ideas that I wouldn't have thought of. And so from that standpoint, I think they're constantly teaching me science that I have to read. And, it's pretty fun. I think my job is sort of supporting them, and my writing is slightly better than most of theirs, so I can help them on their writing.
Wow.
Well,
Well,
scientific writing.
and I think cultivating an environment that allows them to, I think about this whenever we're talking about the KEYS program. We're just about ready to launch our KEYS program for 2021. And the fact that a lot of the KEYS students come in and realize that, wow, the researchers don't have all the answers, and how it takes them a second to realize it's like, you don't have all the answers, but we have data, and we keep asking questions, and we try to get a little bit closer. Every day, we try to get a little bit closer. And if we can get a little bit closer, and you cultivate an environment where people are okay with not having all the answers and still asking the questions and trying to find more answers, I think that's success in a lot of research labs.
Well, as long as you throw donuts in there, right?
Donuts, yes. Of course, you gotta have donuts.
That's part of the culture. It's very important.
Culture. Well, I mean, if you don't have donuts, then I feel like the culture just goes straight downhill.
Exactly.
Talk to me a bit more about that culture. So I know obviously those Donut Tuesdays create a community, not only within your lab, but I mean, within Keating as a whole. Why do you think building a community within research is so important, as opposed to everybody just sticking to their own labs and their own benches?
Well, I try to think, and this is true in the hospital as well. It's like, we're all going to work really hard, right? So that's a given. We should try to have fun while we work really hard, because that makes it infinitely more pleasant, right? Is if you can enjoy coming in to see people, as opposed to sort of dread the drudgery. So I think that culture in part is just, I've been super fortunate to have incredible mentors and incredible labs. My postdoc mentor lab was phenomenal. And so I think if you have those experiences, you want to replicate them as much as you can. And in terms of the openness of science, it is so important for us to get feedback from other people, even, just looking at the same problem. If you get someone who has an outsider's perspective, right, they will see something differently, or say like, well, why is that your interpretation as opposed to X? And that just makes you go, oh, you're right, that's equally valid. And we haven't addressed if it could be either of those things, because we've only been looking at it this way. And so I think from that standpoint, it's important to help your science, but really it's just because we might as well have fun while we're doing what we do.
Right.
Well, and I think you're talking, as you see from behind us, our 20th anniversary at BioFive is this year. So we're celebrating 20 years of helping researchers kind of get to where they want to go. And I know you haven't been with us 20 years, but we've known each other a while. And talk about your experience with BioFive, some of the things that BioFive has meant to you.
Well, BioFive is, I don't think I would have come here without BioFive being a linchpin. And in part, that's because one of the former directors was an MD who did science. And Fernando had a really key insight, which is that physician scientists get pulled, as you guys have mentioned, in multiple directions. And if you don't sort of help them make sure they are sticking close to their science, then it becomes, on some level, very easy to end up primarily being clinicians. And that's for twofold reasons. So one, when I go into the hospital and I order a test, it gets done, right? So I get those numbers. When you do something in the lab, it may not work, right? When I work for months on a grant and then it gets trashed, or it just doesn't get funded, or whatever, right? Like, it's just you don't know what's going to happen. And so I think that frustration, it becomes easier to go in and see patients, because I know that's what's going to happen. I know it'll work there. And the flip side of that is for departments, again, because when I'm in the hospital seeing patients, that is guaranteed money, right? Like I see a patient, I sign that note, it is a certain amount of money. But again, a grant, if I submit a grant, I may or may not get that, right? So there's this push for physicians to actually be in the hospital or in a clinic because it satisfies our own need and it satisfies sort of a financial need. And so I think Fernando realized, okay, if you can separate those two issues, then you have a better chance of success, because the person who's a physician will actually not have the option to go there and also won't be demanded that he or she go there. And so that was a really key success. And the second thing that BioFive did is it allowed me, the second thing about this position is Fernando said, okay, you're going to have a science home and you'll have a clinical home. And so my clinical home is neurology and my science home is immunobiology. And that is a super unique opportunity. And because the university is just where it's at, there aren't a ton of people who do basic science who are physicians at the Department of Neurology. And so it would have been really hard for me to be successful just being in the Department of Neurology, because I wouldn't have had people who could read my grants and understand the basic science and things like that. And so BioFive has really been essential to my coming here, because I wouldn't have come here without it, and I wouldn't have had these opportunities. And then, of course, the admin in BioFive are phenomenal.
Stop.
And so, it's a great community, right? It's hard to complain about BioFive.
Yeah, well, we are very happy that you decided to come here, because I remember when you first came on board, and it was, how long has it been? 10 years?
Not quite.
Not quite.
Yeah, I think it's 9. This August will be
Almost.
9.
But I mean, I think you're in a good place when you blink, and it's been, I mean, for me, it'll be 14 years in October, so it is a great journey.
Yeah,
sure.
I wouldn't want to be elsewhere. I mean, again, I feel very lucky to have ended up in BioFive.
Yeah. Well, I love what you described too. I think that's, your experience is what BioFive is all about, right? Bringing in some of the brightest researchers and clinicians, providing them with these resources and these collaborations to make all of these, discoveries possible that otherwise may not have been, if you were just in neurology, and, not having access to everyone in immunobiology. So I think that's really incredible to hear how it's benefited you, and to know what BioFive is doing for, others like you here at U of A.
So last question, tell us something about you that we may not know. That doesn't have to be science related.
I know, it's like, Sean, you pretty much know me.
I know a lot about you, but maybe you have a wonderful singing voice, karaoke star.
Well,
no?
I had this realization maybe a year ago, which is that it's like, I used to be a really fun person. Still are. Well, I say that because, right, like I have kids. Once you have kids, like they take up a huge amount of your time, right? And it's sort of your free time. When people think about, what do you do with your free time? I'm like, I have children. That's what I do with my free time.
You're a soccer coach, aren't you? Or weren't you?
No. My husband does the coaching. I am a soccer mom.
Also important.
Exactly. But I was thinking, I used to always fill out my college bracket for men's NCAA sports. We used to do all these things. So there is a whole world of my life that I will regain as my children get older.
Okay. Well, you have to be committed to that now. So it's like, you're like, I know how to be fun. I've been fun before. Now, this is not me saying it. These are your words.
I can do it.
I think you're fun now, but I mean, that's just my opinion, and I don't want to over compliment you, but
you'll only get more fun once the last one leaves the house.
Right.
Exactly.
Well, I mean, by that logic, I have 3 kids and none of them are in college yet. So I have a ways to go before I'm fun again.
So I'm not saying it impacted you, Sean, the way it impacted me.
Okay.
I'm just saying that at some point I was like, why? You know what it was? I think I didn't have time to fill out like my college bracket before last, like the pandemic was going on. We were doing all sorts of things. I was like, I just can't handle the pressure of the bracket. And then oh, it couldn't have been last year. It must have been 2 years ago, because last year it got canceled. But anyway, that was my realization. I was like, I was fun.
I find it interesting that your definition of fun is filling out a college NCAA tournament bracket. You know, now that I know you like filling those things out, next time I run a tournament challenge, I'm sending you an invite.
Is that just so when I don't fill it out, I can be bad?
No, I'll harass you a little bit, not too much, but I'll be. Excellent. And I'll name the name of the league will be the Fun League. The Fun League. And that hopefully that will encourage me. That will pull you in. Oh, I like
that. An incentive.
That's right.
So thank you so much, Dr. Koshy, for joining us today. We really appreciate it. And we are huge fans of yours and are very thankful that we get to see you. Hopefully we'll get to see you in 3 dimensions again real soon.
It's coming.
Very soon.
It's coming. And we look forward to that time. And we also want to give a quick shout out to your website, the Anita Koshy lab website. This is www.koshylab.arizona.edu.
Again, BioFive, our lab site is very nice and was very nice at the beginning, and it was because of BioFive.
Well, there you go. And we also want to say thank you to all of our guests for joining us today for another episode of Science Talks. For more information on the BioFive Institute, please check out our website at biofive.org. And from all of us here at the BioFive Institute, thank you for joining us.
To our audience for tuning in to another episode of Science Talks. Continue the conversation with us next time as we learn more about the science happening at the University of Arizona's BioFive Institute.